All right. Here it suggests to scale the replicas first. Well, we can do that. It's not going to be very exciting. So here we have 6 instances. All right, so let's go. Okay, so we now have created the deployment specification referring to the blue application version. Well, let's deploy it. But before we do that, so I had to tell curl to accept a self-signed certificate by using the -k option. So as you can see, I'm polling the application. Is this a bash? No, I think this is a Z shell. Yes. All right, so what we are now doing is we are polling the application, and we get a track of the responses. And now we apply our blue deployment. The blue deployment will change to green. Oh, it does say, because we have to change it here. Green. and we'll observe what happens. Ah, here we go. So you can see that there was a hard transition from one to the other. We did not receive mixed outputs. Although we are using the rolling upgrade strategy. And I think the reason is because it's too fast. So it basically changes from, or switches, or that transition goes so far, or happens so fast that the delay here is too high. We can remove the sleep, which will be faster, and change back to blue. You can see that looks different. So as you can see here, we have green, green, green. Then there's an error message because the instance has been terminated exactly during the time that the process was, the HTTP request has been processed. So you get one error message. That this will happen to your clients too. So for example, if this was a backend and you have a JavaScript frontend polling from that backend, during the deployment, one user could see an error. And if that, for example, is requesting transferring money for €1,000,000, well, that would be unfortunate. So you have to ensure that the process in your application is robust against those errors, because they will happen. So again, now you have I am blue, I am blue, I am green, I am blue, 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 green, blue, green, blue. So you have mixed responses, which is exactly what I earlier described. You have in a rolling upgrade, you have instances that will be ramped down and instances that will be ramped up so that they will coexist at the same time. So this is how the rolling upgrade works. The benefit is you don't have a big service impact. You have a failing request here, but you don't have a downtime. So let's change the strategy. We're now blue, back to blue, because we transitioned from green to blue. We're now going back to green. But we're now adding a different strategy. The default strategy would be the rolling update, but we're now applying a recreate strategy. So here we are, 6 instances on blue, kubectl apply, and we're waiting for the magic to happen. Look, here you got a temporary unavailable error message, and look how long this error message occurs. So we also describe the replica set. we describe the deployment, sorry. So now we are back. The transition has happened. You can see that there is a new replica set. 6 replicas are created, and I'm breaking the loop here. And you can see that from unavailable, I am green. Here are some unavailables, and now it's stable again. Now, can you see the difference between the two strategies when it comes to service impact? Imagine this was a real-world application with a lot of users, and they were constantly polling against the application. So while the recreate strategy has the advantage that you don't have to think about your database migrations, for example, because there could be 2 different application versions being incompatible to another. There could be also other dependencies creating a similar situation. For example, dependency to another API schema that changes along with your application version, like combination between a backend and front end. So any dependency like that makes it easier or tempting to use a recreate strategy instead of a rolling strategy. Because with a rolling strategy, you may have to iteratively roll out a certain change. For example, roll out the code first and then apply the database migration after the deployment has been completed. And make your application aware to detect whether a certain migration has already been occurred and adapt to it, which is additional engineering overhead. But as you can see, the strategy, the rolling update strategy, was much faster. Well, in other words, more precisely, it has way less service impact. All we have observed was one failing request, where the request was actually not processed entirely because the pod has terminated exactly during that time. And we could say that there could be even a chance on getting around that failed request if there's a grace period for a shutdown and your application gracefully deals with a shutdown signal by, for example, finishing the request and then shutting down. Especially if the requests are processed in a small amount of time, this could actually work. But nonetheless, without going too much details, the rolling upgrade strategy obviously creates less service impact, but it requires your application to be robust enough to cope with 2 versions running at the same time. You have questions so far. Have you understood what we have observed here? Do you want to discuss or comment on this?
What I want to know, is there a rule of thumb or something like that for when to use one over the other? Or
Yeah, the rule of thumb is that the rolling update is a default. So you should stick with the default. You should be aware that you need to ensure that 2 application versions will be running at the same time. So you as the application developer, you need to balance the effort you have to put in to make this happen. And what this effort is, only you as the developer can judge about this. There's no answer to this question in a vacuum. But as a rule of thumb, you'd ask me, I would say there's a cost for service impact. So let's say, for example, you have a ticket booking system and the ticket can't be booked. So the customer may never come back again, but book at a competitive offering, with a competitive offering. So you'd be losing a client to a competitor. Well, that creates a certain damage. Or you have a client and it's purely upset. He will call you and be angry. So why is my application not working? Why do we have a 2-minute downtime? Haven't you ever heard something about rolling upgrades? It's 2020. Make your job, right? So on the other hand, you could have a trivial application that's being used internally to a company only by a few people. So why bother about a few minutes of downtime? Nobody cares about that. And then you have to also look at the effort. If the effort is low, and it only means that you'll have to somehow make a little if statement in your code that will detect whether the new schema is there. And you can remove that if clause, because if clauses are always increasing complexity and you actually need to test them. So it's better to not have them if you don't need them. So you could make that into one version, create a ticket to remove it in a future version. And if that effort is outweighed by the improvement on the business side, well, then go for it. If not, then don't. Does that make sense?
Yep, that makes sense. Thanks.
Good. So always cost benefit. As simple as that. Cost could be effort, like engineering effort, and could also be angry customers, leaving customers, lost business, whatever. You have to look at this, make this little calculation in the context of your particular app. All right. Yeah, I will have to update the extensions here too. For example, we did not get that particular failure message that was in the tutorial here. I did not have to replace. Well, maybe they changed that in a Kubernetes version.